Loops are like automated repeat buttons in programming. They enable the execution of a specific block of code multiple times without the need to rewrite the same instructions manually. C offers three primary types of loops: for loop, while loop, and do while loop. We will cover all the types in our upcoming videos. Now, let's dive into our main topic for today, that is, for loops. For loop is a control structure that allows us to execute a block of code repeatedly for a fixed number of times. It allows you to define the starting point, the number of repetitions, and the conditions that determine how the loop should iterate. It's a very useful tool for automating repetitive tasks. To understand the working of for loop, let's visualize it with the help of a flowchart. First off, the loop begins with an initialization phase, where a variable is created and assigned with an initial value. Think of this as the launchpad, the point from which everything begins. Next comes the condition check, a pivotal step where the loop evaluates whether a certain condition holds true. If the condition is satisfied, the loop enters its body, where the actual operations or instructions reside. This is the code that you want to execute repeatedly. It contains the statements that perform the desired actions or tasks. As the loop completes its instructions within the body, it moves to the update phase. Here, the loop control variable is updated. This update prepares the loop for the next iteration. The update operation is typically an increment or decrement, depending upon the desired direction of the loop. Now, the loop circles back to recheck the condition. If the condition remains true, the loop continues and the loop body is executed once more. This cycle of condition check, loop body execution, and update continues until the condition becomes false. This systematic sequence of initialization, condition evaluation, execution, variable update, and repetition defines the essence of how a for loop operates. The syntax of for loop follows a specific structure. It starts with the keyword for, followed by a pair of parentheses. Inside these parentheses, there are three crucial components, separated by semicolons. The first component initializes a variable, often used as a counter or iterator, setting the starting point for the loop. The second component checks a condition. This condition determines whether the loop continues running. While this condition holds true, the loop keeps iterating. The third component involves updating or modifying the loop control variable after each iteration. This update prepares the loop for the next run by changing the value of the control variable. Following these components, there's a block of code enclosed in curly braces. This block contains the specific instructions or tasks that the loop executes in each iteration, as long as the condition remains true. Once the condition becomes false, the loop exits, and the program moves on to the next set of instructions outside the loop. Let's consider an example to solidify our understanding. Suppose we want to print the numbers 1 to 5 using a for loop. It starts with the keyword for, followed by parentheses. Inside the parentheses, there are three parts separated by semicolons. First part is initialization. In this step, an integer variable I is defined and initialized as 1. In the second part, we define a condition that determines how long the loop will run. Here, we set the condition, indicating that the loop will continue as long as the value of I is less than or equal to 5. Moving to the third part, that is I equals I plus 1 signifies the increment operation. After each iteration of the loop, the value of I will increase by 1. This adjustment means that I is updated by adding 1 to its current value, ensuring the loop progresses forward and doesn't run indefinitely. We now add curly braces to enclose the code that will be executed repeatedly within each iteration of the loop. In our case, print is used to print the value of I to the console. Here %d is the format specifier for our integer variable I, and \n creates a new line after each number is printed. Now let's visualize this code in order to get a better understanding. The loop starts setting I equals 1. Now we are checking the condition if I is less than or equal to 5. Yes, it is, so we enter the body of the loop. Inside, the first thing we do is print the current value of I, which is 1. Now I is incremented by 1 and becomes 2. After that, we re-evaluate our condition. Since the value of I is 2, which is again fulfilling the condition, the body of the loop is executed again, which is now printing the current value of I, that is 2. And again, the value of I is incremented. This will continue as long as the condition is fulfilled. But as long as the value of I is 6, now checking the condition, and it is false. So we step out of the for loop and move ahead. Let's verify this by running the program. And yes, you can see the numbers 1 to 5 are printed on the console window. Let's do another example. In this program, we are writing the code to print Hello World 5 times on a console window. And obviously, we can achieve that using for loop. I want you to do this example first on your own. Please take your time while pausing the video. Well, now let's do that. Firstly, as we know, our loop starts with the keyword for, followed by parentheses. Let's declare an integer variable I and initialize it to 1. We aim to print Hello World 5 times, so we set our condition I is less than or equal to 5. So that loop continues when this condition is true, and when the value is 6, it should terminate. After that, we update our variable. This plus sign is called increment operator, and it adds 1 to our variable I after every iteration. It is exactly same as writing I equals I plus 1. Now we put curly braces, and inside that, we can put our main code that should be executed in every iteration. Since we want to print Hello World during each iteration, so we can utilize printf statement to display that. And of course, we put \n to change the line after each iteration. Hope you understand this code, and by the way, the flow of code execution is exactly similar to our previous example. Now build and run the code. And yes, you can see Hello World printed 5 times on the console window. That's all for this lesson. If you have any questions or need further clarification, please leave a comment below. If you found this lesson helpful, consider liking this video and subscribing to our channel for more educational content. See you next time. Happy coding!